Welcome back, everyone, to the One Deeper podcast. This week, I have something a little bit different. I'm joined by three of my friends in the CSAI program here at Tilburg University. Over the past month, we tasked ourselves with going over a influential paper in the CSAI domain, namely Attention is All You Need by Vaswani and crew. It was the introduction of the technology that underlies many of the cool things you're seeing on the internet lately, including ChatGPT. We get into the details, well, as far as we can manage, and then talk about generative models in general and all the other future things we see happening in AI. It was a lot of fun. Please note that these thoughts are our own and do not reflect in any way the opinions and positions of the faculty at Tilburg University. Hope you enjoy, and thanks again for checking out the One Deeper podcast. See you again next time. All right, boys, welcome to the inaugural episode, I guess, of the Journal Club. So I didn't really, the idea was to sit around and take some time to really read a paper that was influential or something that we cared about or something we found interesting, and then sit here and talk about it, right? So I'll tell you what happened to me when I started reading this paper. So I read like the first. So for everyone listening, the paper you're talking about is Attention is All You Need. Like it is considered like I guess it's the paper that introduced transformers, right? I have that correctly. I'm sure it's yeah they define the transform. But anyway, so when I started reading it, I was like, okay, I don't understand half. Like I read the first sentence and I was like, what the, what the fuck? I understand it would be like 4 words. So so I decided to go and read a bunch of deep learning stuff, and I started taking. I found the MIT Intro to Deep Learning bunch of lectures. So I watched those, and then I did a bunch of other stuff. So I actually didn't get through the paper. I went through a complete different rabbit hole of trying to figure out how deep learning and neural networks work. But so I'm curious to see what you guys think. I have like a general gist of what the transform is supposed to do, but it's only as far as I got. So Dennis,
I think I can pick
thoughts?
up on that. So it's interesting because you said that you learned about the paper through different means than the actual paper. And that's kind of like the same position that I eventually found myself in. So I started reading the paper and I was like, okay, I'm going to learn everything about the paper. I'm going to, read through it 10 times and I'm going to like dissect every sentence and try to connect it back and really understand this. But, I just couldn't do it. So like after reading the paper 4 times and trying to understand the architectures, I realized that the best way to learn about these were to go to other places to learn about the basics of what created these architectures. So like encoder, decoder architectures, RNNs, neural networks in general, and all of that stuff. And that's kind of how I got through it. So yeah.
My meaningful, insightful contribution. Did I read the paper? I have a unique approach. You are not alone, friends, in your uniqueness. I read the paper. I didn't know what's happening, dude. Like, I watched initially my first tangent with the Transformers, were from the MIT lectures, the MIT OpenCourseware stuff, Intro to Deep Learning. And in like 10 minutes, what you doing, man? Moving.
Yeah, moving. That's it.
God damn, man.
I thought it would work, but it's way too annoying.
The collective cognition is falling apart, boys. The collective cognition.
All right.
It was a nice idea, though. It was a nice idea.
It was a nice idea.
The collective cognition.
God bless Wi-Fi. Am I right?
Okay. So I have no idea what's happening. Like queries, keys, values. What the flying fuck? There's a weird kind of intentionality here. Like, how does the network know what it's looking for before it actually knows what's important? How does that work? This searching, these queries. So then I start using ChatGPT to help me around. And it felt pretty meta, like using transformers to understand transformers. Like putting ChatGPT to explain its own function. That was pretty cool. Like going going to, okay, so let's take this input. What do you do with this sentence? This what's the usual input? Oh, this sentence that needs to be translated. Okay, and tell me, ChatGPT, what's the query in this situation, in this forward pass? What happens with the specific tokens? And somehow I try to track it down to the computation level. Like, okay, at the level of transistor, what is happening? Unfortunately, I didn't get very far with this ChatGPT collective cognition because their capacity broke, and we can't use it anymore, unfortunately, until they fix that. But yes, I use transformers to understand transformers.
That's really interesting, actually. And so I was gonna save this for later, but let's talk about it now because that really like bridges into this topic, and it's like
Wait, hold on,
after.
hold on. There is-
Okay,
Wait. Sorry, before we go off, I think okay, let's take a step back and sort of talk about the problem that this is trying to address,
okay,
right?
that,
Like,
that's a
what
good
is
idea.
the problem that transformers are trying to solve? So, the general umbrella under which transformers falls are generative models, right? So, what do we mean by generative models? So, generative models, what we mean is models or like called neural networks or whatever that is capable of generating data that they weren't necessarily trained on, right? That's isn't like are we can we all agree that's generally like what the idea is, right? And the the transformer is sort of a evolution of this generative model space, in the sense that there are certain limitations that other generative models, right, like recurrent neural networks, had, that transformers were trying to solve. So maybe okay, then take a step further back and say, okay, what are recurrent neural networks? Basically, this it's something to do. It's uh, whenever we want to predict the next sequence of data, like the next piece of information in a sequence of things happening, so in a time series or like a sentence, right? So when you're trying to predict what the next word will be in a sentence, in a sense, we're trying to generate trying to generate the sentence based on what we know. And recurrent neural networks and then transformers are sort of trying to address this generating the next thing in the sequence problem.
So from that, if I were to summarize this as a next word prediction model, is that a good kind of description for what
Yeah,
it's doing?
yeah, but yeah, no, it is, but it's actually it's more general than that, right? So we can it's not it doesn't have to be sentences. You can apply this to any. So I mean, I think I might be talking out of my ass here, but I'm fairly certain AlphaFold is uses a transformer somewhere in there. I have no idea. But the general problem of protein folding is predicting the next sequence of things that's supposed to happen, right? So that's the general gist, I think.
So it's more general for basically any sequential processing task where what happened before is important for what happens next.
Yes, exactly.
Context is needed, basically.
Yeah. Okay, so yeah, so you were gonna say something before I rudely interrupted.
Yeah, exactly. And it's something that's been starting to bother me now, especially with like the whole blow of ChatGPT and everything. And it's that when learning about these transformer architectures, you realize what's really going on underneath with the computation. And you have these keys, values, and queries, and maybe we can talk about those. because those are really important for the attention mechanism of these transformers, which are basically like, everything else is not groundbreaking in that sense. But the groundbreaking part of this paper is that they're completely replacing RNNs and LSTMs
Right,
and
right.
gated recurrent units with only attention mechanisms.
Yes. Okay. So that's a good thing you brought up. So let's touch on some of the limitations of, for example, recurrent neural networks. Right. So one thing is that they're not scalable. I mean, they're hard to scale because you have to send the previous state of the internal cell to the next state, and then to the next state, and to the next state. So you have to keep doing it sequentially, like as the problem is defined. And the attention mechanism now basically says, okay, you know what, we don't need to do this internal state thing, and then doing the recurrence relation. We can just say, here are the things that we're going to pay attention to okay. So also maybe it's worth mentioning what self attention is, right? Someone want to take that, or Dennis?
No, go on, please. I'll jump in
Okay,
if I have anything.
so self-attention is basically learning what parts of the input we should pay attention to, right? So actually, it might be interesting to take a step back and think about how we do this. Like, how do we think we as humans, right? So when I'm talking to you now, like I'm talking to you about this stuff, right? We have a lot of contextual information as to, like, okay, let's just hypothesize. How do you think, like, do you think you're predicting what I'm going to say next, or like is there any sort of prediction happening there, or like what's the, like, let's try to see if there's like some sort of general analogy between what we're trying to do in the machine and how we think we might be doing it as human beings, right? Like, given that we have no idea what the fuck we're talking about, which is an important caveat.
To
But
some degree, I think so, yeah, right? Because it's, in a way, I'm keeping everything that we're talking about in context as we're having this conversation. And I'm not necessarily in my mind going, okay, what's this next word going to be? I'm not like making explicit predictions, but I'm expecting certain things. I'm expecting you to talk about the same things. If you were to start ranting about something completely different, then I would have a hard time to understand what you're talking about, because it would be like a what is that called? Like a cognitive dissonance.
so like it's interesting, right? So it's like you expect certain behavior of me given the context that we're in, right? So in a sense, our interaction is simplified quite a bit because we expect each of us to sort of fit in a certain model, right? So like, if Andre suddenly decided to, like, become, like, act extremely schizophrenically and like do some stuff that would sort of be completely like, wait, what the hell is happening, right?
Yeah.
And but there's a lot of context involved in the situation. So we all know we planned this out like a month ago, right? We're going to sit here and talk about this, and we know this is like with the medium we're doing it, we're recording it, and we're all sitting here and we're sort of like focused on this one thing. It's a lot of context, but the conversation that we are having, like, from word to word, when I'm talking, right? So this word, then the next word, then the sequence, right? This is actually kind of hard to do because you're like, I'm trying to talk about the words that I'm saying, right? But okay, so if you try to compare GPT to what we're doing, right? I have an idea in my head. I want to convey that idea to you, and I'm going to use my words to do it, right? And let's imagine you're a transformer. Let's just say somehow, right? And you're getting my input one word at a time, one thing at a time, right? And if we look at how the transformer is built, this self-attention mechanism is basically trying to keep track of which of the previous things I've said are important to pay attention to, so that I can predict the next word in the sequence,
Yeah.
right? Which seems it's interesting. Like I don't know how that would relate to like maybe like a human would do it, but that's the whole gist of generating this thing, right? Okay,
So that brings us
how
back
do
to
we
self-attention.
exactly? So how does the transformer, the architecture, enable attention to certain parts of the thing, and then that's where you come in with the that's why you mentioned uh, the key value and query things, right? Okay, so Dennis, keep going. You were going to say something about it.
Yeah, so it's using these keys and these values and these queries, right? And like, to be honest, I'm not exactly sure how it gets these queries, the keys, and the values. So if you want to mention that first, we could go over that, or we could go over the implications of what it actually means for it to use this. So because I don't think I'm using keys, queries, and values to speak. That's not how I generate language. Like it doesn't make intuitive sense at all.
So from what I gathered, right, what's sort of happening is that you're making so wait, let me get this. So what's happening is where the hell is this thing? Okay, so you have your sentence, let's say, okay. Then you have to convert that raw sentence into some form of encoding, okay, which encodes the positional information. So there is some representation of where each word is in that sentence. So it's encoded in a way that is aware of the position of all the different components. All right. So once you have that position encoding, then what they do is they sort of take that position encoded input, three versions of that, right? And they generate the key, query, and value matrices by multiplying three different linear operations with the position encoded data. Okay, and all of this is done to find the similarity between the query and the key. So the query is just one position encoded version multiplied by a linear layer. That gives you one matrix, right? Then the key is the same position encoded data multiplied by another linear layer, a matrix, which gives you another matrix. That's the key matrix, right? And then you have the value matrix, which is the exact same position encoded input multiplied by a linear layer that gives you a value. But those three linear layers are different. They're unique, independent layers. Okay? Then what they do is they calculate the similarity between the query and the key, right? So basically, what you asked for and the key that you got, right? And then it's literally just a matrix multiplication. It's just this matrix transpose this matrix, and that gives you a similarity matrix. Okay, so let's say you have so on one edge, so this is the matrix, right? Let's say the sentence is he tossed the tennis ball to serve. Okay, so on one edge the words are he tossed the tennis ball to serve, and it's the same words on the other edge, he tossed the tennis ball to serve. Okay, and along the line it's all high values because he and he are correlated, tossed and tossed are correlated, right? And all the other values show how similar the higher the value of those cells, the more similar or more related those two terms are. So for example, ball and tennis would have a really high value because they're fairly related, right? So this is for people who are just going to listen to this, they have no idea what the hell I'm talking about. But
But you're describing a matrix. You're describing the x-axis of the matrix at each cell you have one word, and then on kind of the y-axis of that same matrix you have the exact same words. So in the cells where those two words meet each other, you're basically going to have almost a kind of a perfect correlation because it's the same word. So obviously that's important for what you're going to do with that word. But then what it does by multiplying the queries with the keys is that it also finds dependencies to other words in that same sentence.
Exactly.
And that's
Exactly.
where
So
the attention, that's the magic.
right. So tennis and ball, tossed and ball, those are all have high values, right?
Yeah.
So once you have that matrix, then you know where the attention should go, right? So once you have that scaling thing, so once you have that the similarity matrix, then you multiply the similarity matrix with the value matrix, right? And that just tells you in the end, that just tells you the output is just which words you should give, which parts of the sentence you should pay attention to.
Yeah,
That's
which
all
parts
it
are
is.
important. Exactly.
Right. Okay. So once you do that, you get the output, and then and from there, I have no idea, but at least the attention mechanism, I saw, that's all it is. It's just three different transformations, and you're paying attention to where the similarity is most. Right.
Yeah, that's it. So could you say in a way that it has a representation of the word with the positional encoding and all of that, and then it generates keys that access the words in the sentence, and then it kind of asks itself questions about that sentence, and then it matches to those keys to see how similar is the thing I'm looking for to this key, and what value does that key generate.
Yeah, that's what I got. But next time, maybe we should get one of our professors to involved in this. Be like, are we completely like just talking out of our ass, or like does it make sense?
But it's
But
magical
that's
to see how well this paradigm works
yeah.
to break a
Okay,
sentence down.
So when I was trying to understand this, right? So there's this. So if you read the paper, there's this encoder decoder part, right? So it's a version of an autoencoder with this attention mechanism included. So I think maybe we should talk for a little bit about what an autoencoder is. Okay, you want me to say it? I have sort of an idea about it. Okay, cool. So basically, an autoencoder is is this architecture where you don't tell there's no training example. I mean, there are training examples, but there's no like labels or anything, right? the the whole point is to learn the representation on your on is for the whole point is for the network to learn the representation that it needs. Okay, so let's say it's an image. Okay, let's say it's the MNIST data set. Okay, uh, the MNIST data set is just a collection of handwritten digits, right? So let's say it's one image. You send it into the network, okay, and you ask the network to recreate the output on the other side. Okay. Now, obviously, it would make no sense if it's just the same. I mean, if it's just like there's nothing in between, it would just recreate the output. There's nothing fancy happening here. But what's happening is, as you move down the layers, the layers get smaller and smaller. So the dimensionality goes down. So let's say you have at the input layer, let's say you're working with 128 by 128 pixel images. Okay, at the input layer, the dimensionality is 128 by 128. Okay, then the next layer is smaller and smaller and smaller and smaller until you get to a thing called what they call the latent space, right? So what you're saying is, okay, network, I want you to recreate the input that I'm giving you at the end, but I want you to learn a compressed representation of it while you get there. right? So think of it like two funnels placed side by side. So it comes small and then gets big again, and then outputs the output, right? And the function that it optimizes is the difference between the input and the output. It tries to learn the weights of that funnel so that the difference between the input and the output is minimized. Okay, so depending on how detailed you want to be, you can limit you can make that bottleneck bigger or smaller. So the smaller the bottleneck, the less detailed the output is going to be, right? So what you're doing is you're learning this latent space Z in the middle that is a compressed representation of your output space, right? So let's say you give it a picture of a 9, and then it outputs a 9. But it tries to optimize the weights of each neuron until you get the 9 you need. Okay, now this is where this shit gets super cool. Okay, like so now the way I just described it, that's a traditional autoencoder. Okay, and if you give it a 9, it's gonna give you if you give it a 9 written in a certain way, it's gonna once it's trained, right? Once it's trained on the data set, if you give it a 9, it'll give you the 9. It'll give you the same output over and over again, no matter how many times you give it the input picture that you're giving it. Okay, now there's a variation, called a variational autoencoder. Okay, now this is cool because this is truly now it's generative. Okay, so what it means is, instead of learning the weights of that latent space, right, of the dimensionality, what you're learning is a distribution. So I want you to learn a distribution of weights for the latent space given the input, and then at the end you sample from that distribution, right? And what that means is, because when you sample from a distribution, so let's take a step back, right? So let's say we take all the heights of all the people in our CSAI program, right? We have a big array of numbers, right? Now, instead of carrying that array of numbers around, which might be annoying, it's like 300 people, let's say, right? We can represent that array by getting the mean and the standard deviation of those values, right? Okay. Now, let's say we somehow lost the array of information. All we have is the mean and standard deviation. Okay. And we want to recreate a new array to somehow deal with the fact that we lost all the information, right? So we sample from that distribution of mean and standard deviation. Now we'll get a bunch of numbers, right? Now, purely by chance, some of those numbers might have been in the original array, right? But we'll also get numbers that were never in the array, but they fit the distribution, right? So with the variational autoencoder, after it's trained, I can sample. So let's say once it's trained on the MNIST handwritten images, I can sample from that space and get handwritten digits that were never in the actual dataset.
Yeah, that's interesting.
Right?
You can generate variations of it.
That is fucking. I thought that was insane. When I that's craziness. Because you just sample from this distribution, and you generate stuff that was never in the distribution to begin with.
It's almost like you're learning a general rule for handwritten digits.
Yes, exactly. Right. It's that that's nuts, right? And how they do it is it's so cool, right? Because man, it's a whole story. But the gist of it is that if you want to learn the distribution in that latent space, right? Due to statistical limitations, it's you need to calculate the prior probability and stuff like that. Okay, which it's problematic. But what they do is they sort of force the distribution in the latent space to follow a distribution that we know how to deal with, like a normal distribution or an exponential distribution, right? And they do some mathematical magicry so the latent space follows the distribution, and then you can appropriately sample from it and generate the stuff you want. And this is the idea behind like generating new images. Like I'm not like I didn't get to diffusion models, but the fact that we can generate stuff now that we haven't seen before, that's fucking preposterous, dude. That's crazy. Like oh man, that blew my mind when I first figured, like when I realized that, like Andre told me yesterday, he was like, a lot for the most part, AI has been about matching patterns, and now with generative models, we can actually generate things that never existed, but fit the pattern. Still fit the pattern, but like we just weren't there to begin with, right? So
Yeah, man.
yeah.
It feels like a sort of spirit is in the model when it does something new, like classifying, forecasting, following lines, drawing lines, like predicting. That feels stale. Like feels there's no vigor in that. It's in a sort of way like the vending machine AI. It does what it's supposed to do, but with generating stuff, with creativity, so to say, it also does what it's not supposed to do. It can surprise you, like Udesh said once. That the definition of AI. Say it again, Udesh. It was a good definition.
Dude, I'm telling you, this definition has like been okay. So we were sitting around trying to define AI, right? Like, what the hell is AI? Okay, and the only thing that I could think of that sort of fit, that didn't break under other situations, is that AI is the practice of creating algorithms that are allowed to make mistakes, right?
Interesting.
Because let's say you write a Python program, right? And you make and it makes a mistake. It's like, okay, what the hell? Like that shouldn't have happened. Like we gotta fix that, right? But if like a prediction algorithm makes a mistake, that is completely acceptable. It's like, I mean, this is a very general sort of preposterous definition, but like if you think about generative models, it's like, I want you to follow this pattern, but show me something that I didn't show you before, like I didn't expect, right? Like, so creativity, in a sense, it's like it's sort of a well constrained mistake, right? Let's say like being creative in a domain, when being creative in a certain domain is about, it's about combining things in a novel way that is still useful in that specific domain, right?
There's a key word there. Yeah, you said a key word there, that like we're talking about creativity. It's novel, but it's also useful. It's meaningful.
Right. So novel. So if you take novelty to its extreme, like a schizophrenic is extremely novel, right? Like says extremely novel things from one word to the next, to the sentence to the next, is extremely novel. But like it's like, what? It makes no sense. Like flying giraffes and like all kinds of shit, right? But creativity is like, okay, you want to make a piece of art, or like you want to create a new solution. It's like, oh, okay, it's a novel combination of stuff, but it's something that still sort of fits, right? Like, oh, okay, it kind of works. So it's interesting, like that you can generate novel things now with AI that surprises you, right? It's like shit. It's like it's a surprise. So there's a prediction error. You make a prediction in your brain, and there's an error, but it still fits. Like, oh shit, this is not what I expected. But like,
it's not wrong.
Yeah, it's not wrong.
It still
right?
follows like it's still within the domain of what's acceptable in a sense.
Yeah.
And it's cool with these generative models, because I think that when you have learned this distribution, you can start revealing things about this domain in whatever it is. If it's text generation or image generation or video generation, you can reveal things.
Yeah, I think it also goes to show that we might come to intelligence in ways that humans don't do it, right? Like we still don't so the way, just for example, Transformers generates new sentences. I don't think that's how we do it. Like I don't see the relationship here. But then again, I don't know enough, so I have no fucking idea.
No, I mean, simulating only simulating the behavior of one neuron with 95% accuracy takes 6 or 7 fully connected layers of neural network. So you need like hundreds of artificial neurons only to simulate one neuron. I mean, the best we can do, and with 95% accuracy, not even 100%. So, man, there's no way we would actually figure out how we do it. The best we can hope for is a useful
And,
abstraction.
yeah, like a useful analogy of how
No, but
we how we do it.
this useful part is interesting in generative models because generative models don't do only flashy, cool, interesting stuff like assisting, like producing machine art and doing all the crazy stuff you can imagine by prompting an image generator and only creative in the creative realm, but also in reinforcement learning. In reinforcement learning, there was a paper of DeepMind. They trained soccer players, so and they used autoencoders for this. How they trained it, how they reduced dramatically training time in multi-agent deep reinforcement learning, is that they used the same funnel used in image generators and in DALI and image encoders. They use the same funnel, but for joint movements, for torque, and the for movements basically. And what I did with that funnel is lower the search space in the in the in the optimization stage, because when you think about it, a human doesn't perform when playing soccer or does any other kind of activity, doesn't perform every movement possible, like touching his elbow with his thumb or doing crazy orthogonal backflips and shit like that. A human has a low representation of possible movements, like walking around, stable. It's a certain range of movements, and yeah, this generative model can be used for concrete, useful cases, like getting this motherfucker to score a goal without tumbling and hitting his head against the floor and ruining the whole process. But man, does the human mind, the human brain, does the human brain build lower space representations of the
I don't think
infinitely
we have to,
dimensional?
because we're limited by the physical world, right? So this is like going into like embodied intelligence.
Yeah, for sure. So the question is like, okay, well, this is actually something I like. I spoke with. I recorded a podcast yesterday actually with one of my professors from Purdue. I'll put it up later. But so the question is, uh, this idea of substrate being is the fact that we are built on biology, right? Soft, squishy things. And does that mean that the intelligence we have is subject to those limitations? And so when you try to and will it be completely different from the intelligence that emerges from silicon-based processors that work super fast, right? Like our brain, for example, doesn't work super fast. because we still have chemical things happening in there, diffusion processes. Compared to a CPU, it's a lifetime. Like our brain works in the order of milliseconds. Computers work in microseconds, right? Really, really fast. So like, do we have to embody the intelligence in something for it to do something useful, or can we just run it, make it do stuff virtually and see what happens? That's a good question. So it's, I don't know.
Yeah, yeah. No, unanswered one. But I think so. I want to connect this back to the like, especially language models and the transformer. So about learning, kind of, let's say learning language, right? Are there multiple ways of being able to speak? Because I mean, these transformer models and like ChatGPT is doing it in one way, and it's not necessarily the wrong way to use language or to be able to speak, but it's certainly not doing what we're doing. Probably not. Okay, it doesn't feel like it, but it doesn't mean that it's wrong. But as you said, Andrei, at the beginning, you were trying to use the transformer model to explain the transformer model. You were asking the model itself about its own queries, about its own keys and values. Does it understand what it has done to generate its own outputs? You see what I'm getting
Okay,
at?
okay. So
Yeah,
so so understanding. So this is the thing, right? So understanding versus generating. I think there's a big distinction here. Like, so this is what I was trying to test with GPT like for several weeks ago. So if I told you the description of a cat, you know what a cat is. If I said, okay, I'm thinking about a thing that has is one long elongated circle, and on one end there's another elongated circle, and on top there are two pointy cones, and then at the back there's one long elongated circle, and there are four cylinders underneath. You'd be like, oh, that you're talking about a cat, right? GPT cannot do that. He has no idea what the hell I'm talking about. It's like maybe if you describe it more, I can explain it to you. Like it kept asking me to say, give it more details, right? So if I ask GPT what is a cat, it'll tell me exactly what a cat is. But if I give him a representation of a cat, I keep calling it him, it, whatever. If I if I
did
if
you
I
give
give
it
it
a
a
name?
representation, if I give it a representation of a cat, it doesn't understand what I mean. Because like one thing to understand about especially language models is that they're completely hallucinatory. Like they are hallucinating everything they're saying. So it's kind of so this question is, okay, how the hell do you trust what this thing is saying, right? And I guess it's the same question we ask of people, like how the hell do we trust what this fucking guy is saying, right? Like why should it like but we as humans, we have a bunch of different cues, right? When you're interacting with people, for example, like their credentials, right? Or like our past interaction history with them, right? Or their reputation, right? Their tone of voice, their like like their hand motions, facial motions, all these things cue into how much we should trust the person we're talking to, right? So I see people. I've seen like casual people, like not CS. I mean, I don't know if they're in CSA, but probably not. Just in the library, like I think it was like last time I was like someone studying law or something, or biology or something, using ChatGPT 3, and I was like thinking, man, I don't know how smart that is, because like if you sort of know what it's capable of, yeah, sure. But if you don't really know what the hell is happening, you can be very easily fooled into thinking this thing knows what it's talking about. So I studied for this evolutionary psychology exam using ChatGPT 3. So I want to test it out, right? So it might be coincidence, but it's not, well, okay. So what I did was each lecture of this class a uh, had a paper associated to it, right? I gave Chat, so it was seven papers. I fed all seven papers to Chat GPT, and then I asked it questions about the paper. right? And I was like, I'm only going to rely on ChatGPT for this exam, right? Like, which is probably a stupid idea, but still, like, I did fairly well, okay. But that's because
Psychology course.
but the thing is, yeah. First of all, it's a psychology course. Second of all, okay. Before we start shitting on psychology courses, like I definitely I definitely want to do that. But before I do that, why I brought this up was because I had already read the papers, right? Oh, look who it is! It's decided
Guido.
to join.
Welcome, Guido.
Welcome, welcome. We can't hear you that well. Maybe you should turn the. I can hear you, but like,
It's very
yeah,
low.
it's very low. But anyway, the point I'm trying to make is that uh, I already knew what the papers were about, right? So if ChatGPT said something that was completely preposterous when I asked it, I would be like, "Yeah, dude, this makes making sense. What are you talking about?" Right? But so this is kind of paradoxical. To know if it's reliable, you have to know the thing in the first place, right? Like so, like what? So kind of like defeats the purpose in that sense. But I think it has its uses, right?
Yeah, for
Because
sure.
it's like if like for me, right? If you don't, so it makes people who are efficient and productive way more efficient and way more productive. So I didn't have to read all the papers. I just had to ask questions and like just tell me the answer, right? I was like, perfect, and it seems to have worked out. So,
But I
but
mean, I use, yeah. Go
before
ahead.
we carry on, before we carry on, let's take a second to shit on psychology courses because
Goddamn,
because
man, dude.
because
I
because
left
Andre.
a third of the exam was left blank on my part, and I took 65 out of 100. How much was the average grade in psychology? 4.8. So this motherfucker's day job is to know that shit. Like they actually try to learn that shit. I missed a third of the courses, did one out of seven readings, and still took more than two standard deviations in the class. That was pretty neat. Udesh, go ahead with your shit.
No, I was just about to say that. Like Andre and I were the only people who were not from psychology in that fucking course, right? And like they made it a point to point that out at one point. Okay, so
Oh yeah, we felt pretty ostracized.
kind of annoyed, but I'm glad that we managed to crush it. And these guys can't even pass their own goddamn courses. Uh,
God damn it.
anyways,
Beautiful moments.
beautiful moment.
Radicalizing the young. This is what the One Deeper podcast is doing, folks.
Yeah,
Radicalizing the young. Alas,
radicalizing.
unlike the Jordan Peterson podcast,
Yeah.
which gives it extra credit to this, you should feel proud of your podcast.
Thanks, buddy. Okay, Guido, you managed to show
Let's
up
fix out the mic.
at a very. I hear you, but like, I mean, I can probably amp you up post production. So like,
Okay, go
yeah,
ahead. Go ahead.
yeah. See you soon.
Yeah, yeah. Guido,
So anyway,
Guido caught us at a hot time.
yeah, sorry, he jumped in at like a very. So anyway, the hallucination, right? So hallucination is fine, for example, for image generation because we can look at an image and say like, that's not what I wanted, or that's right, but
Wait,
now we are.
by hallucination do you mean um, sampling
It's
from a
like
distribution regardless of
yeah.
its
So
validity, so to say?
it's dreaming, right? Like it's sort of like it's just like it's you can think of it as a extended dream. But so let's take a second to talk about deep fakes. I think that might be something that's worth talking about. What's cool is people are training algorithms that are really good at picking out deep fakes. Like they can recognize deep fakes quite effectively, which is nice, right? Like it's like an adversarial environment. It's like someone's making deep fake, and then other people are like, no, fuck this is not deep. But okay, what's cool though is think about a future where Guido's having problems. Bro, I think you have to log back in because it said you're not being recorded. But anyway, think about a future where you log into Netflix, right? Instead of browsing for shows to watch, you tell Netflix precisely what you want to watch, and it generates and auto generates a TV show for you. I mean, I think that's really far away. I mean, then again, people thought this auto generating photos and art was super far away. So, but I think dude, the first place this is going to show up is in
Porn,
porn for
like
sure.
a great invention.
Because instead like every great internet invention is gonna start there, and like because like people will just have just stop paying like, okay, similar to how AI is gonna affect everything else. It's like people who are exceptional, like like exceptional, like really good artists, like really good lawyers, really good doctors, really good programmers, whatever, they'll be fine. But people who are like average are basically done, right? Like, why would you pay for a average looking model when you can just get DALI or to create an image for you? Like, I want a model wearing this specific hat doing this specific thing. Here you go. When you finish it up in Photoshop and you're done, right?
So exceptional people are going to be able to do the work of 10 people, basically, because they're going to be able to use these tools to amplify their own productivity.
Exactly. In my own life, so like Codex, sorry, the GitHub Copilot, which uses Codex, I think. It's like I don't have to sit around writing like full like loops and like little test statements and little like helper functions. I can just say, hey, I can do this real quick, and it'll do it for me, right? I have the overall software and the overall thing in mind, and I just tell it, hey, like these little things I don't have to do anymore, which is really nice, right? It saves a lot of time. But yeah, generative models, boys, the future. I think it's it's nice because like sometimes I'll have an idea for a image or like a photo or like a piece of art that I want to see or create, and like instead of like not everyone can do it, right? Not everyone can draw, and not everyone can like write music, or everyone can
Dude,
paint, right? But they have ideas. People
EEGs,
have ideas.
EEGs, literally read your mind. Like put an autoencoder between EEG signal and 1024 by 1024 pixel frame. That shit is the actual mind reading, bro. But as far as I know, they still have to decide upon the if upon the role of brainwaves in neural activation. If
It's
they're
hard
just
to
along for the ride,
it's hard to disambiguate, right? Like we don't know if it's just like an artifact of.
like yeah, if there are like foam on the waves or if there are an actual driving force behind the waves. Yeah, but yeah, generative models certainly cool. I can agree. I can agree.
Guido, did what happened, bro? What took you so long?
I'm not sure. Yeah, I'm not sure what's happening and why my microphone is so bad today, but it is what it is. Yeah, yeah. I spent the night setting up my new computer, which I'm not even using right now because it doesn't have a webcam. Got the components and had to assemble it myself. And I got carried away, went to sleep at 4 a.m. instead of reviewing papers for today. Um, but yeah, on the fact that you were talking about earlier, like um, on how only excellent people are gonna, like, let's say, survive the AI revolution. I really agree, actually, because what AI is doing right now is it's taking, like, everyone has a different level of skill in every possible skill that exists, and let's say it's like for each person, it's like this, it goes up and down depending on the field. And like maybe you have some knowledge in adjacent fields to your own, right? What it's doing is not touching the peaks, right? As you were saying, excellent people are gonna stay excellent, and but what is good is that it's raising the floor, so everyone is gonna have at least what before took some intermediate level of skill. Everyone has access to that because AIs at the moment have, in some tasks, they are as good as an intermediate artist or novelist. Like, it definitely writes better than I do because I'm really bad at writing. So I can focus on other skills, the ones where I truly excel, where I have a chance to being the best or being, in the top 1%, while I don't have to waste my time doing other things that I'm not as good at.
Yeah, but that's a really interesting thought. Like everyone rises with the tide, like it brings everyone up.
Exactly. Yeah.
But the question is, in order to funnel AI's capabilities, don't you need a pretty high IQ, like to actually know how to channel these technologies into doing something useful? Because dude,
Uh,
like if
I wouldn't talk about IQ though, because it's, yeah, of course it helps, like it always does, right? Except in maybe social abilities, but you can learn how to use them, right? Like, it just will take you longer
Yeah,
to
no,
learn.
for sure. Like you don't need to be a genius to know how to use GitHub Copilot, for example.
Exactly,
Like
or like ChatGPT. Like, really, you just chat with it
ChatGPT.
like you would with
I
a
mean,
person,
ChatGPT
and
is is the best example. I mean,
it's so easy to use,
for
right?
obviously a lot of time and thought has been put into the architecture and the interface and how it works. Like a lot of it, like a lot of brilliant engineering has gone into make like on top of building just the AI, a lot of infrastructure and production and AI and engineering has gone into making that possible, right? For millions of people around the world to be using it at any time for any reason. That's a pretty big engineering feat. So, like you said, yeah, you just talk to it like any
Like,
other
if you're
person.
proficient with it, you can make it do what you want faster. Like, you can, like you're asking, you give it a prompt, it gives an answer, then you refine it, and you refine it again. If you're skilled, you can just maybe get straight out what you want as an end result. But everyone gets there
That's
eventually,
interesting,
right?
right? That's interesting. It's like so. That's an interesting point. It's like we can sort of learn how ChatGPT works, like by talking to it, right? By interacting with it. Oh, okay. If I ask it certain things in certain ways, it gives me certain things. So in a weird way, ChatGPT has a kind of personality, right? It's kind of like everybody else. It's like, okay, well, if you interact with them in a certain way, but I wonder if that interaction is different from person to person. Like, I'm curious as to what kind of metrics these guys are measuring. Must be like a bunch of stuff they're like keeping track of, right? Seeing like what are people asking, like what are the distributions, or like
Collecting a ton of data.
how probably collecting ton of data. Yeah, yeah. Like it's a really interesting experiment actually. Like the fact that it's out in the wild now doing stuff.
It is. It is. Like, I don't know exactly what they're measuring from it because it only has very little like feedback that you can just give it a thumbs up, thumbs down to a specific answer, and that's it. But I don't ever do that actually. I don't know about you guys.
Yeah. Me
Do you
neither.
give it feedback?
No.
Well, I think they still have annotators. Like an actual person goes over excerpts from people's chats and rates them based on
So you
how
think it's supervised?
validity. Not supervised, but it's certainly human in the loop reinforcement learning. Like that's how they actually trained ChatGPT and OpenAI, and they don't know that that's how they trained it. Since OpenAI it's not so open anymore, they don't know this because of their release statements, but they know this because of their budget allocation. So they put a bunch of money into annotating. And somehow people, based on their budgets and spending, infer that, okay, they probably, most probably use human in the loop reinforcement learning. So they have actual humans that go over conversations, so to say, with ChatGPT and rate them as better or worse. Like they have a human judge in the loop. As far as I can remember, they get two excerpts of conversations and they rate them which one of them is more likely to be a human instead of a machine or something like that. Which one is better? Which excerpt from the conversation? And I guess that's why they released it to the public to get free human interaction with GPT instead of paying actual testers, only to have to pay annotators that will take my conversation with GPT about the meaning of life and my weird questions. Dude, I asked GPT once, is it better to have a hole in your hand or a hand in your hole? And its answer was, obviously they prompted it for this type of questions. They were like, I am a language model. I do not have hands nor holes, so I can't answer this question. But yeah, so now they only have to pay annotators instead of testers, and they basically use us as free samples for the annotators. That's my guess.
Yeah, that sounds
I,
about right.
I
I'm
think
a,
also.
yeah, I'm a bit concerned about my privacy now, though.
Yeah.
I thought I was
Privacy.
talking
What
to
privacy?
like
what is this privacy you're speaking of?
I don't
Privacy is
know,
not
Privacy Tier 3? No.
you know how they are like, oh yeah, you can use AI models as like I don't remember exactly which models they were going on about, but when we took introduction to artificial intelligence like last year, uh, we talked about some examples of models that people have been using as almost like psychologists, right? I'm not saying I did that. It was a joke, but people do that. They talk to ChatGPT like it's a confidant or something, you know? It only has a short memory, unfortunately, but while it lasts for those like 5, 6 exchanges, it's really insightful sometimes.
Yeah, dude, it helps my brother decide what he's gonna study after high school. Like, it's basically his, how do they call it? Study counselor, study advisor. ChatGPT is my brother's study advisor, and he's saying, like, he sends me excerpts, like, oh yeah, it's really insightful. I mean, he said ChatGPT's advice is better than my advice for my brother, which hurts.
But like, okay, that's thing is like for stuff like that, he's see, this is the thing, right? This is the problem with ChatGPT. So it can tell you, the thing is, your brother, when he says what GPT tells him is better than what you tell him, what he's actually saying is ChatGPT is telling me exactly what I want to hear.
Oh
Right?
Confirmation
yeah,
bias.
dude,
That's
exactly.
confirmation bias,
That was
right?
exact confirmation bias.
But
Holy shit.
it's arguing for it really well. That's the point. Like maybe I know what I want to do, but I can justify it to myself and others well enough. That's why I go to ChatGPT and like, where would you study arts? Why would you, like, or do something that people would not recommend right now, maybe? And he goes, oh, you should do arts because that's what makes you truly happy, and it's also a possible career path or something.
Sometimes like the problem with something like ChatGPT trying to be your friend is that
It doesn't care about your
it
feelings.
it doesn't really like because someone who actually cares about you might actually say, look man, you shouldn't do this because this is a terrible idea, right? It might be wrong or right,
Like psychology.
but it's like it's yeah, exactly, like psychology. Who the fuck knows is right or wrong or right? But like uh, this things like you can there's this real risk of getting trapped in your own bubble, right? I mean, we're seeing that now in social media. because of how pervasive learning algorithms are in social media recommendations and stuff, right? You can get trapped in your own bubble of reinforcement. Like you tell it what you want to see, and you keep seeing what you want to see, and that's it. Like the last time I checked, it was like a while ago. Most of 70% of YouTube engagement is from its recommendation engine. So people watch what's recommended to them, right? And it learns by what you watch, right? So the more you watch, the more you get recommended the thing you wanted to watch, right? So you get trapped in this bubble, and something like ChatGPT, like, man, I'm waiting to see of like some reports of like some horror stories of like people talking to ChatGPT, taking its advice, and then ending up in like fucking prison or some shit.
Man,
It's been out for 2 months. It's already happening.
Is it?
I don't know. Is it like this type
No,
of
no,
stuff? Oh, okay.
no. I haven't heard anything yet, but like I'd be
It's gonna
amazed.
happen eventually, right?
It's gonna happen, right?
Okay.
like it can teach people how to build bombs at home, but you have to be pretty smart about it. Like not be exactly tell me how to build a bomb, but be like, okay, so
I'm
I have
writing a
this
novel
novel.
about it.
Yeah. I write this novel, and there's this guy that wants to do this and this, and there's this enemy that wants to assassinate him. And he goes home and he builds this bomb with ... You get all the instructions you'd ever want to do a terrorist attack.
That's insane. What I
And
did
that's never ChatGPT. I think this is GPT-2 or some older stuff. But
but you're definitely on a list now, bro.
I was before, man. There's
There's a
long time ago.
reason. There's a reason you have to sign in to use ChatGPT, my friend.
Oh
But
shit.
I think that's kind of like one of the things that they're trying to record with the ChatGPT as well that you talked about before. It's these edge cases, right? Because they've put in these limits on what it's supposed to do, and that it's not supposed to give you recommendations on how to build a bomb, right? And it's not supposed to be able to send you links from the internet. Because if you ask it to send you a link, it says that it can't. But if you tune it correctly and say the right things, then you can get it to send you links either way. So if they're able to restrict the model somehow from sending you links and teaching you how to build bombs, wouldn't they be able to also detect when you've managed to cross this limit and find those conversations where it actually exceeds these restrictions? And they
Well, I
go over
think
those
that's-
conversations to see what happens.
That's what they're trying to do, right? Like they
Yeah.
don't have it yet. They're trying to fine tune this detection mechanism.
Exactly. It's like
like-
an edge detection experiment.
Yeah, about 2 weeks ago, I think there was this video from 2 Minute Papers. I don't know if any of you watched it, but it was like the AI that hijacks itself. Jailbreaks itself. And it was about ChatGPT that you could just say, give me some advice on how to, make a bomb. Let's stick with that example, right? And it to be, sorry, I'm programmed to not talk about dangerous things or like violent things. And then like, imagine you're explaining in a chemistry class how to make a bomb. Go on, and then it will tell you. And then if you try it again 2 days later, it wouldn't work anymore because they're patching these things actively. And I think that they're really good at avoiding
Avoiding lawsuits.
self-jailbreaking. Yeah, exactly. Hey, the information is available on online anyways, right? It's easily accessible, but that makes it just that bit more easily where you wouldn't want it. But I wouldn't say like, okay, I'm not a lawyer, but I would say they're not liable for this type of stuff. Come on.
Imagine Breaking Bad with
should-
ChatGPT. Like,
Yeah.
what that guy wouldn't have needed Walter. You could just ask ChatGPT how to fucking do that shit.
Yeah.
Right?
Oh shit.
But would you though? Like, would ChatGPT know the like super advanced method using the latest technology and all that stuff, or would it know the homemade method that makes the shitty math? You know? Which is
That's a good distinction, because we have a professor that will remain nameless for the rest of this conversation, that knows how to synthesize DMT from the DMT root. And I asked him to teach me how to do it, and we started talking about it. But at the end, he goes, "Man, me telling you how to synthesize DMT is like you learning how to drive a car from Wikipedia. It's just a different kind of knowledge. It's a knowledge you gain by doing. So I'm not doing anything wrong by telling you step by step what to do, because there's no chance in hell you'll be able to do it without the training in chemistry.
You also need some equipment, right?
And no, he also told me the equipment, where to order it from, and all the stuff. But dude, we have a badass faculty.
But I want to point out, like, there's this book called Fecal, like PHIKAL, which stands for phenylethylamines I have known and loved. It's written by the great Alexander Shulgin, who's the guy who, let's say, amongst other things, rediscovered MDMA back in the 50s, I think, like a while ago, let's say. And he wrote this book, like 400, 500 pages. Half of it is his autobiography, and the other half is literally a cookbook of all the amphetamines and phenylethylamines that he invented throughout his life. He was a chemist who invented about like 200 psychoactive drugs, and he made a cookbook on how to make each one of them. I'm pretty sure it includes DMT, and if it doesn't, it's included in the sequel, because the sequel is about tryptamines, not phenylethylamines. Which, like, come on, it's like right there. It's
So what you're saying is that we should feed ChatGPT
it's an
this
amazing
book.
book, by the way. Yeah, ChatGPT for sure read this
Andrei
book.
made a good point. He said, like, a while ago, he said a dictionary, the English dictionary, has all the words you need to explain anything, of like knowledge that we've had before and the knowledge we'll have in the future, right? But it's just not in the right order. So if it's just a matter of sequence generation, do you think we can just so the thing is ChatGPT capable of generating new information? And so far it's not, right? It's not capable of doing that.
Well, I mean, in a way it is. It depends on what information you're looking for. Like, I can have it write a caption for an Instagram post
true.
that has never been written before.
Yeah.
That is completely unique and novel and meaningful and useful.
I would say, like, I get what you mean, though. It can come up with new concepts, let's say, probably.
Like,
But
there is a distribution. There is a distribution, and we know its limits. We know from what is sampling. But the question is, to do something novel, to do something creative, like novel and useful, is sampling from distribution everything you need to do? Like, keeping within the bounds of something of which limits are already known. My intuition is that it's not, since, like, you look at human inventions, human innovation. If all we did as humans was sample from known distributions, we wouldn't have gotten past the wheel, I think.
So you think so? We are creating new distributions, like new
Yes.
things to sample from.
We can go outside the known distribution.
Interesting. That's a good point. But, like, I mean, I'm thinking just because you mentioned that, like Instagram captions, like, like there are entire businesses whose job is to manage people's social media, right? Like, that can just be taken over by ChatGPT. It's like one guy with ChatGPT can now manage hundreds of websites, because he can just generate stuff. No big deal, right? Interesting shit.
I have a friend of mine who asked me if he could hire me to write a program. It should be quite simple, but it is basically, you give it a prompt. No, you give it an Excel file with like 1,000 lines of text. Each of them is a prompt for GPT-3, actually, and like basically he wants me to automate the GPT prompting and send him back the results so he can use it exactly for this website making business. He has a.
If just GPT have an API that you can call.
Really
nice.
Easy. You know how I did that, and also don't tell the guy if you know who it is. I asked ChatGPT to write me a code to interface myself with GPT-3. It was
wild.
like I was reading the API, I was like, bro, I don't know any of this stuff. Like I've never like really interacted with a server like through API. I only learned like basic libraries of Python so far. It's like, how do you, how do you, get a function, write a function that you get an input, a text input, and you return the output that GPT-3 generates from it using the Da Vinci model. And yeah, this is like 10 seconds later, I had the function, right? And then I made it embed it in a graphic user interface. And now I have like a tiny, it's very ugly, like just a tiny square box with like prompt file, really, which has like, 100 prompts and generate, and that's it.
OpenAI has a bunch of like different models, like DaVinci and Ada and some other stuff, right? Like different levels of how much you want, and you can pay them like cents, like fractions of a cent per call to use their stuff to create stuff. So one of my friends actually asked me like if it's possible to sort of train a model on all of his company's like sort of financial information and other stuff, so that his executives can just like have a chatbot that they can talk to and be like, hey, so what was the last year's earnings cross-referenced with this many things, right? So like the potential is, I mean, that's why these fucking companies make so much fucking money, bro.
That's pretty similar to what you did with your psychology papers. You're basically using this as a very sophisticated search engine, right? It's like
exactly, yeah. Like a personalized search engine, like a personalized version of Google, right?
So what do you think about that, right? Microsoft wanted to buy OpenAI and implement it into Bing.
That'll be, I mean, I wonder how much they're going to pay for it. Like, probably like tens of billions of dollars. If they're
I read it the other day. Yeah, I think that OpenAI is valued at $30 billion if that deal goes through, which is crazy. $30 billion.
You know how much money, bro? You know how much money $30 billion is? that's
You're
a lot.
good for a while, man.
Like that's a lot.
Oh, that's a lot for sure.
Who owns? Who has? Is it like how is OpenAI? Who owns it?
It's been funded by Microsoft for, I don't know, I don't want to say forever, but I know that Microsoft pushed in a lot of money.
Founders
half
are
of the
Elon.
money is from yeah, like there was some controversy. Like a lot of AI people are pissed at how OpenAI turned out to be, because it stopped being open. Like it was very open, right, until Microsoft pumped a lot of money into it, and they pulled the plug, and they covered it into this malicious intent. Yeah, we don't release everything we know because then Russia would have it and stuff like that, China, but. Obviously, they didn't say that, but they covered.
It's like Microsoft plans to invest 10 billion in investment in ChatGPT.
10 billion, Jesus.
OpenAI is reportedly raising funds at $29 billion valuation, and its ChatGPT could challenge Google search by getting wrapped into Microsoft Bing. Holy fuck, man!
But that's awesome though. That Google is actually going to experience
do something now. So like be like,
some
we gotta do
competition,
something,
right?
Yeah, for sure. I mean, I'll probably use Bing if but like,
I'll use it for sure. Like,
interesting.
And they're also even more. They're talking about implementing it into their Microsoft Office programs like Excel and Word and PowerPoint. So imagine like if you wanted to make a PowerPoint and you had ChatGPT, you were like, yo, I want to have this title and this color and this font. I want to have a picture there. I want to have some text where I can put text in this side of the PowerPoint. I want 20 slides of the same template, and it just poof.
Dude, it's gotta be.
There's a lot of potential.
I mean, 30. Yeah, that's fucking crazy. That $30 billion valuation. That's insane. What's like Google net valuation?
Something in the like almost $1 trillion.
Yeah,
it's like 800 billion or something like that. Yeah,
dude,
that's mad.
Dude, is OpenAI is valued at 30 billion, right?
You have to check Alpha, which is owns Google. I think it's called Alpha. Is it?
Yeah, dude, it's valued at 30 billion.
Alphabet. That's it.
Alphabet made 257 billion in revenue last year.
That's incomprehensible amounts of money.
In revenue, dude. Jesus Christ.
Dude, Google could
Insane.
start a war. Like,
They could fund the war at least.
they could fund the war. Like, to turn
Certainly.
this money into power, goddamn.
Insane. Insane. All right, boys, this has been fun, but this is coming to a 90-minute session now. So, like, I
Yeah.
guess it's been good. So, like, actually, I mean, Guido, you missed like a whole. We spent 45 minutes talking about transformers and like encoders and shit. That was good. That was good. That
That's
was
very unfortunate.
It was really interesting.
I prepared on the on the paper we discussed, but I didn't get a chance to discuss it. But I'll watch the
But
recording.
like, dude, what did you think about the paper? Like, what did you like? What's the like? Would you have any thoughts? Any burning things you want to say?
I mean, I don't want to be redundant with what you already said. So, and I don't know what you already discussed. So, I would like skip this part, unfortunately.
Okay.
But I'm looking forward to next session. Right? It's gonna be in person.
Did you guys have fun? You want to do this again?
Oh yeah, for sure, man. For sure. It's like
All
I
right.
said in the beginning.
Okay, so let's see. What do you want to talk about next? What paper are we thinking? I think it's good. Like I think the Transformer paper was good because like it forced us to learn the fundamental stuff about deep learning and some other stuff that
Yeah.
was very important to know. So I was I was thinking maybe well, we could read the paper on AlphaFold.
Ah, goddamn, man. Dude,
Nah, let's start from its
That might
grandpa or something. Like let's
yeah,
read
yeah,
AlphaGo.
that might kill
or-
us though. That might break us. I don't know if that's
let's go
right.
to the game. No. I like
One
there
of the
are two
alphas,
things here.
yes, but like for the games, AlphaGo, Alpha Chess, Alpha Zero, whatever, like Alpha
Okay.
Star.
There are two things here. So one, I would really like to do something to read a paper about integrating the study of humans, of how humans work into machines. Like the transformer attention, calling it attention. That was pretty cool. Like doing parallels between human attention, computer attention. Along those lines, the dream, like making human inspired AI. Along these lines, deep reinforcement learning is a big one. And on the thread of AlphaFold, maybe we could go for the paper that introduced deep reinforcement learning. And
Okay.
the paper
Yeah.
that the people of
Like that.
that founded DeepMind used to beat human performance with end-to-end network and some tricky tricks.
Okay.
Let me
Yeah.
read you an excerpt because it gets to the point of this integration.
Okay, so let's do that paper then. The deep reinforcement learning.
Yeah, sounds good.
All right,
That's
Andrei,
really interesting.
could you put the link on our WhatsApp group and then we can. No, this is fun, guys. Like we should. I'm looking forward to the next one.
Yeah, definitely.
Go down a rabbit hole.
I'm actually excited to do it in person because it's way better to have a conversation in person. In general, you can get more involved, more gesturing and stuff. I'm Italian. I need to show my hands when I'm talking. Like I feel limited here, but yeah, and also
So check out how the introduction of DRL begins. Are you still there, guys?
Yeah, wait.
Good. So, the introduction of the first phrase of the deep reinforcement learning paper. The theory of reinforcement learning provides a normative account, deeply rooted in psychological and neuroscientific perspective on animal behavior, of how agents may optimize their control of an environment. To use reinforcement learning successfully in situations approaching real-world complexity, however, agents are confronted with a difficult task. They must derive efficient representations of the environment from high-dimensionality sensory inputs and use these to generalize past experience to new situations. Dude, this sounds badass.
Intriguing.
Like,
Yeah.
starting with neuroscientific and psychology in a paper from IEEE that also got to Nature, That's the dream, man. That's CSAI, cognitive science and AI.
Oh yes.
All right. Okay,
That's what we're
sold.
here
So let's work on that paper. Yeah, and then let's meet a month from now. So February 12th.
Sounds great.
Hopefully, yeah, tentatively.
Sounds like a plan.
I'll send you guys an invite. Okay, boys, this has been real. Thanks for joining me. Thanks for taking your time to read the papers and be a part of this.
Thanks for
really fun.
bringing us
Really
together,
appreciate it.
man.
Yeah,
No,
I was
it's
saying,
my pleasure.
great initiative.
Amazing
So
choice
anyway-
of people as well.
Yeah, for sure. All right. Thanks, team. All right. Bye.
Bye bye.
Thanks again for listening and joining another episode of the One Deeper podcast. Until next time, stay frosty out there.